In this episode, we shall explore the transport equation. The transport equation is an equation that describes the movement of a property in a fluid. As a slow start, just accept that the transport equation is simply a differential equation. Solving the transport equation will give us phi, where phi is a function of space and time. Phi being a function of space means that at different locations, phi generally takes on some different value. As an illustration, at x1, phi is phi1, at x2, phi is phi2, at x3, phi is phi3, and so on. Phi being a function of time means that in general, phi at all points change with time. Here's an illustration. We kept talking about phi, but what really is phi? Phi is some physical property being transported in a fluid. Commonly, this could be temperature, concentration, or momentum. The real world is a three-dimensional space, but for simplicity, we shall confine our studies to one-dimensional problems. So instead of using the 3D transport equation, we shall be using its 1D counterpart instead. In this equation, there are four terms, namely the temporal term, the convection term, the conduction term, and the source term. Let's unpack each of the terms and its symbols. Rho typically denotes the density of the fluid being studied. The term gamma is found in the conduction term, and we refer to it as the diffusivity constant. U refers to the fluid velocity. So what does the source term refer to? Imagine we have a stream of fluid. Suppose we want to study the temperature of the fluid stream. If we put a heating element in the fluid stream, it now becomes a source of heat, so we can represent the heater as a source term. Recall that some chemical reactions are exothermic. The release of heat in the fluid stream also becomes a source of heat and can be modeled as a source term too. The direction of fluid stream does matter. In one-dimensional problems, if the fluid is flowing in the positive x direction, the value of u should be positive. If the fluid flows in the negative x direction, the value of u is negative. In summary, if the fluid flows right, u should be positive. If the fluid flows left, then u should be some negative number. We must learn to recognize each term when given a transport equation. The temporal term is represented as a derivative of phi with respect to time. The convection term is represented as a first derivative of phi with respect to space. And finally, the diffusion term is represented as a second derivative of phi with respect to space. It may not be obvious that this is a second derivative with respect to space, but we can simply see that from the symbols of the derivative operator. Let's count. 1, 2. And so this is a second derivative with respect to space. Any other terms can be lumped together as the source term. If you found this to be a helpful guide in understanding the transport equation, remember to donate me and support the growth of the channel. Until the next video, see you next time.